All right, this is a demonstration of pure water and pH. And the explanation should start with what pH is. And what pH is it's the science of water. Anything that contains water contains hydrogen and oxygen. But for over 100 years, man has realized it contains something else in it. And that is a plus or minus hydrogen ion. And the importance of this is that the amount of hydrogen ions, the balance of hydrogen ions, which is pH, determines whether a substance is a water at 7 or an acid at, let's say, 1 or lower than 7, or a base at higher than 7. So what I'm asking you to do here is open your mind. I'm pointing down at subspace. So first, what we have here is pure water. And pure water is parts per million. We test it with this, a TDS meter. Where am I here? Okay. And that one was 9. This is tap water. It's sitting at 569. This one here is also pure water, so it's at 16. So these two are pure, and this one is the dirty tap water. Now, what you're seeing here is water, because we know this because of this. This is a pH scale, and this is a little portable tool. And what this does, it has a little glass electrode in there, and it uses a little battery, and it fires an electrode, and it figures out it senses how many free hydrogen ions are there. It's actually only looking at the negative side how this works, but that's okay. Don't worry about how it works. It actually does work. And what it is showing is a moment in time. This is just a test. What we're doing here is we're chasing ghosts. We're looking at things we cannot see. And what that little instrument tells us is that this water sits at 9.1. pH is 7 is neutral. So water should sit at 7. So this is actually sitting on the high side. This is closer to a basic alkali, and what is that tells us is that there's more positive charged hydrogen ions in this water than there is negative. In the tap water, the pH is 8.3. Okay, this one's high again because, once again, this probably has some calcium or it has so much garbage in it, it's probably high because of the mineral content. And then, once again, this water here, see, it sits at 9.6, which, in theory, for this to be water at room temperature, it has to sit at 7. And that's what I'm trying to hit at here. This isn't water, and this isn't water, but this is, see? And the reason is because this loses its pH. And what happens is all the free hydrogen is going wacky. It's not under control because in this water, there's stuff for the free hydrogen to grab onto. In this water, there is not. So that free hydrogen is running willy-nilly. And to say, I don't believe this or I don't understand this is to say, I don't believe the science of pH. I don't believe the science of water. I don't understand water. And if you ask yourself, you probably don't understand water, because in this society today, we're so disconnected from life. Is that ask your pool guy about pH. Ask a farmer. I can personally tell you from experience of growing golf courses that pH is the most fundamental principle in the health of plants. Humans? I think so too. Now, let's take this here glass of water that sits at 8.6, pure water. And once again, this is my nitric acid I showed earlier. This is my fake stomach acid I use. It's a pH down, pH 1. And I'm going to add 1 drop of water to this 8.5, because you know what I'm going to do? I'm going to grab the hydrogen atoms in here, I'm going to grab these ghosts by the neck, and I'm going to pull them down to the negative side with 1 drop. Yep, so 4.8 that is. So that is an acid now. That is not water. Your eyes say, yeah, that's water. No, you're wrong. See, it looks like water, smells like water. I ain't tasting that stuff. Drink it. Yeah, that is not water. The definition of water is pH neutral 7. This is not pH neutral 7. And that is why we can go and play the trick to the other side. Okay? Here we have, this water's been sitting here. And see, pure water by itself this water changes because it grabs stuff from the air. Hydrogen, so powerful. I mean, but it grabs stuff. It's looking to grab stuff. So let's give it a little sodium bicarbonate. And with that sodium bicarbonate and alkali, we've taken that water up. We've taken that water to a 7 point, it'll get around 8. And then once again, we can take our substitute stomach acid and show that to change that solution takes a whole lot of stomach acid. I mean, really, a whole lot. See, that crashes down and it comes back up. And you know why? The free hydrogen is controlled. And I know that's hard to see, but once you understand what I am saying here, it becomes very clear.